Okay, so that was pretty easy. The section 7.3, hopefully you watched that. Maybe you skipped it because you figure you know it so well. Now we're going to go on to section 7.4. And 7.4 involves we're going to put everything together. Fractions and equations. Alright, so how's that going to work? We touched on this a little bit last week, but we'll review something similar to what we did last week. Let's say I have a problem like this. Solve 4D divided by 3 equals 12. Now some of you look at this right away and say, oh, yeah, no problem, I got this, 40 over 3 equals 12, you know exactly what to do. Well, I know, the problem with this is fractions, and nobody really likes fractions. Some people are better than others, but nobody really digs them. So I want to come up with some clever way to get rid of this fraction first. So we know that 4D divided by 3, or 4D over 3 is really division. A fraction is division. We're dividing by 3. So I'm going to multiply both sides. I'm going to say put parentheses around here and put parentheses around here. I'm going to multiply both sides by 3. All right, well, what good does that do me? Let's take a look. If I multiply both of these by 3, oh, look at this. I don't even need that pen. The 3's here cancel out. That's pretty nice. So then I can say 4D equals... Oh! Do you hear that guy coming? This is my teaching assistant. Are you my teaching assistant? His name is Walter, and he crawls. And yeah, here he comes. Okay, we're going to pause for just a second here because Wally says I'm making a mistake on this problem. No, we're just going to finish it, and Wally can argue later. We're going to divide both sides by 4. And divide both. Yeah, Wally says that's a good move. And then what happens when we divide by 4? These 4's cancel out. And then this will equal, what is this going to be, Wally? What's 36 divided by 4? Wally, oh, 9 you say? Oh, yeah, it is 9 he says. So we're going to say that D equals 9. All right, now, but we didn't really do anything that special there. We just multiplied to undo division and then divided to undo multiplication, right? And so we got the answer. However, if we take a little bit harder problem, we'll see that we can take a very lazy approach, and this could work out pretty well. Remember, a good mathematician is lazy. So now we have to solve, what about negative 1/4 x equals 9 minus 2/3 x. Okay. Well, this could be a serious hassle. Hassle number 1, we have x's on both sides of the equation. Hassle number 2, we've got fractions multiplied by our variable. Hassle number 3, they're negative. Oh man, what a hassle. I mean, this is just a huge pain. We could move this over here, and then we've got to find common denominators, blah, 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 and that'll be a real mess. So we want to make this easier. Make this easier. Well, I'm going to be clever here and say, what would the common denominator be? What would the lowest common denominator be? And that would be 12. So I've got a 4 here, 3 here, 4 and 3 both going to 12, so let's use 12. So now what I'm going to do is multiply everything by 12. So let's rewrite write this negative 1/4 x equals 9 minus 2/3 x. I'm going to multiply everything by 12. You know, what about addition and subtraction, getting rid of fractions? Well, we'll see here, 12 and 12. And when I do that, I can see that, well, the 12 and the 4, they kind of cancel out, right? What am I left with? 12 divided by 4 is 3. So I can say this is negative 3x. Why? Because 12 over 4 is 3, and it's still negative, so that's 3x. Equals 12 times 9. Well, 9 times 10 is 90. 9 times 2 is 18, so that's 108. So that was kind of hard, but look at this. Minus the 12 over the 3 cancels out there too, right? What's 12 divided by 3? That's 4. So that's 8x. So 2/3 of 12 is 8 is another way to think about that, but 12 over 3 is just 4. Times negative 2 is 8. So now when I add, something seems wrong about this one. When I add the 8x to both sides, that is, if you hear that noise in the background, Wally is stacking 8 Tupperware cups as a demonstration. So here is, this becomes negative 3 plus 8 is 5x equals 108. Now this isn't going to work out terribly well, because that's what happens when you make up problems. Divide both sides by 5. Well, 108 divided by 5, x will equal, 5 goes into 105, right? That's 21 times. And then there's 3 left over, and so I've got 21 and 3/5. Okay, so this is possibly the hardest step in the whole thing, the 108 over 5, getting to 21 and 3/5. If you struggle with that, what I could do is say 108 divided by 5. Well, 5 goes into 10 twice, and then 2 times 5 is 10. No remainder there. So it's just an 8. 5 goes into 8 once, and that's 5. And I'm left with 3. So that's my remainder. And then so that's 3/5. That's where that comes from. So x equals 21 and 3/5. Okay, we're going to pause for just a second. Okay, there we go. I had to kick my assistant out. Alright, so here's this fraction problem, but again, we're starting to do some hard math problems. And it's like, what's the point? Why are we doing this? And again, I'm an engineer. Math is supposed to be a tool to solve real problems. So let's take a look at a real problem that involves this. Let's talk about electricity. Let's say we've got like the positive end of a, electricity. Right, and this is what happens when an engineer is supposed to come up with a real-world example. Let's say we have a plus side of a battery here, and we've got the minus side of a battery here, and it goes through a resistor like this, and then it goes to another resistor here like this, different resistor, and then another resistor like this. And let's say that this one here is 25, and the symbol for resistance is this thing here, ohms, and this one is 75 ohms. You know, these could be car parts or light bulbs, and let's say this one is 300 ohms. That's the Greek letter omega. If any of you ever joined a fraternity or sorority, that's omega. And we want to figure out, now the electricity has a choice. You could go through the 25 ohm resistor, but that's a lot of juice to go through one resistor. Some of it is going to go through here, and a little bit will actually take the long way and go through the 300 ohm resistor. Right? So this is a, say this is a like a heating coil, and this is maybe a light bulb, and maybe this is something like, I don't know, something else. Well, it turns out that, you know, total resistance, when they're going through resistors in parallel, is going to be, the formula for that is 1 over the total resistance equals 1 over the first resistance plus 1 over the second resistance plus 1 over the third resistance plus, and that keeps going on. But we only have 3, so we'll only do 3. So we have 1 over our total equals 1 over 25 plus 1 over 75 plus 1 over 300. So we'll do the same thing. We've got all these fractions. What a hassle to deal with. So let's find a lowest common denominator. Right? Looking at this side over here, the lowest common denominator, let's do that in blue. So over here the LCD is what? Well, 25 goes into 75, so we could do 75. Oh, and 75 goes into 300. So actually, 300 would be a nice LCD here. The lowest common denominator could be 300. Problem is, over on this side in orange, the LCD is something we don't even know. The LCD is just the total resistance. That's the only denominator. So the LCD, the lowest common denominator for this whole side of the problem, equals 300 times the total resistance. And we don't even know the total resistance, and our LCD now contains a variable that we don't even know. But let's apply the same technique. Where am I here? So we multiply through everything by the lowest common denominator. The goal is to get rid of the fractions. So I have 1 over r equals 1 over 25 plus 1 over 75. That's a 7, Greg. Plus 1 over 300. Now, I'm going to multiply both sides by the LCD. So times 300r times 300r. And so what does that work out to be? Well, 300r times 1 over r, that's convenient because the r's cancel out. And then let's break apart the other side just to make sure that that works. So 300, the r's cancel out, so that just equals 300 over here. And then that equals, we have to distribute this now, so it's 300r over 25. Right? Plus 300r over 75 plus 300r over 300. Well, this cancels out too. There's some stuff over here. 300 divided by 25. What is that? Well, 25 goes into 100 4 times, so it goes into 300 12 times. And 75 goes into 300, 75, 150, so that's twice, so 225, 300. So this goes in here 4 times. Oh, and here, that's pretty nice, the 300s just cancel. So this whole thing Now that I multiplied through everything by the common denominator, I have a new equation. 300 equals 12. I still have my r, plus 4r plus r. So 300 equals 12 plus 4 is 16, plus 1 more r is 17 r. And now to undo that multiplication, I'm going to divide by 17. Divide by 17. And now that one is a little hard to do in my head, so I'm just going to do it out. 300 divided by 17. 17 goes into 30 once. That's 17. So that leaves a 13. So 17 goes into 130. Well, that's a tough one. How about like 6 times 17 is 6 times 20 is 120. That's pretty close. 7 times 20 is 140, but it's not actually 7. So I'm going to try 7 here. So 7 times 7 is 49. Put the 4 up here. 7 times 1 is 7, plus 4 is 11. Ooh, that worked out. So it's 110. So I'm going to put a decimal point here. 17 goes into 110. 6 times. 6 times 7 is 42. Put the 4 up there. That's 10. So that's 8. Yeah, so, you know, let's say it's roughly this. Approximately R equals 17.65. It probably keeps going on and on and on and on. But whatever. We'll just say R equals 17.65 ohms. And that's our answer. All right. Now, before I came down with this little pink eye issue, I spent the weekend cutting, or I think the lumberjack types call it blocking firewood and then splitting it. And so it brings up an important question about splitting firewood. All right. Now I've discovered that Dress can split one cord. Firewood is measured in cords of firewood, so that's a big pile of firewood, in let's say 3 hours, roughly, if things are going well. Now I have a buddy named Schrader, firefighter actually, Madison firefighter, can split one cord in, well, let's say 5 hours. Nice guy, very smart guy, but I'm just a little manlier. I can split firewood faster than he can. So the question is, how long does it take us together to split one cord of wood? All right, now these are always tough problems. I'm going to write in down here, just in case somebody really gets freaked out. Don't get freaked out, because these are hard. I'm not talking about hard wood like the elm that we were splitting, but these are hard problems, so you want to take some time and study these. Let's quick review or learn about rate. All right. So we're going to say that there's a formula: work equals rate times time. All right, another formula that we've learned here. So an example of that, Well, a really common rate is, let's say I drive 65 miles per hour for 3 hours. Well, how much work did I do? I mean, granted, driving is not that much work, but work equals the rate, which is always something divided by time. So it's 65 miles per 1 hour times 3 hours. Well, something kind of cool happens here, that the units actually cancel out. I've got units, hours on the bottom here and hours on top here. Those actually cancel out. And what I get is work equals 65 times 3 is 195 miles. So I take my rate times my time, and that says how much work I did. All right, let's do another example. Let's say I can grade another work example. And for me, it actually is work. I can grade one quiz in 3 minutes. Okay. How long to grade? I have, I think, 70 to 73 college math students. How long to grade 73 quiz? Right? Bad English, but you get the point. Well, what is my rate? My rate is 1 quiz divided by 3 minutes equals 1/3 quiz per minute. Alright, well, I know that work equals rate times time. And so then I know that work, I need 73 quizzes. That's how much I have to do. Equals 1/3 quiz per minute times time. I don't know what the time is, so that's still a variable. Well, here again, so I could write this a little easier. 73 equals 1/3 t. I could multiply everything through by 3 to get rid of the fractions. 3, 3. And so this winds up to be, oh, look at this, my 3's cancel. That was kind of nice. That 3 cancels with that 3. So 73 times 7 is 21. So 3 times 70 must be 210. 3 times 3 is 9, so this is 219 equals t. So the answer to my question is 219 minutes. 219 minutes, that's kind of a strange way to say that, so it's almost 4 hours, right? So, you guys think it's rough that you have to spend, 30 or 40 minutes taking a quiz. Well, it takes me 4 hours to grade them all by the time you're done. Well, how about another example? Another work example. And again, this one for me is actually work. So I can do, or I could do, I worked at a bike shop in high school and college, and I could do 4 tune-ups in 1 hour. All right. Now I'm going to say how many tune-ups in a 6-hour day. Why 6 hours? Because nobody at bike shops ever really works 8 hours in a day. There's a lot of coffee and music and lunch breaks and goofing around. I mean, I love working at a bike shop. It's a ton of fun. But I still like bike mechanics. Every year I have a bike mechanic in a class, in at least one class. They're all good guys, but they typically don't work 8 hours. So, my rate, right, it's 4 tune-ups in 1 hour. So 4 tune-ups in 1 hour. So that equals 4 tune-ups per hour. And again, I know work equals rate times time. So let's see, the work I don't know, so W equals rate, which is 4 times time, which is 6. So W equals 24 tune-ups. All right, great. Oh, that's not a question mark. I was about to ask a question. So my question was not about tune-ups or grading quizzes. What was my question about back here? It was about, oh yeah, Dress can split 1 quart of firewood in 3 hours. Schrader can split 1 quart in 5 hours. How long does it take together to split 1 quart of wood? All right, well, let's take a look at that question. So let's go back to our firewood. So, Dress, 1 cord, 3 hours. Schrader, 1 cord, 5 hours. So how long together? All right, so let's look at Dress. That's me. What's my rate? My rate is 1 cord in 3 hours. So that equals 1/3 cord per hour. And then let's look at Schrader. So how much, so let's say, how much in, no, we'll skip that. We'll do Schrader first. So we'll do Schrader. His rate, right? What is his rate going to be? 1 cord in 5 hours, so it's 1/5 cord per hour. So remember that work, I'll do it here, work equals rate times time. Work equals rate times time. How long are Dress and Schrader working? Well, I don't know, right? That was the question. So they're working for T hours. So how much work did Schrader do? Or let's say, how much work do I do? Dress, work equals 1/3 times T hours. Schrader, his work is 1/5 times T hours. Right? So again, it's rate times time. So it's rate is 1/3, 1/5, and the time is going to be time and time. We don't know what the time is. So the total work, though, is 1 full cord. So Dress's work, which is 1/3 t plus Schrader's work with his 1/5 t has to equal 1. Because that comes from, now I'm running out of colors, let's say green, right, here is my time. And then let's do Schrader's in dark blue. So Schrader's doing this much time. That's that. And our work together has got to equal 1 chord. Holy cow, this is a long problem. So let's go back to black ink. So we have 1/3 t plus 1/5 t equals 1. So 1/3 t plus 1/5 t equals 1, multiplied by what's the least common denominator? Yeah. What's the least common denominator here? Well, 3 and 5, the number to use to make all these fractions go away is going to be 15. So we do this one more time. So we have 15 over 3t plus 15 over 5t equals 15. We can do a little canceling here, make life easier on ourselves. Well, let's just write it like this. We don't have any fractions left, because 15 over 3 is just 5t plus 3t equals 15. So 8t equals 15. Divide both sides by 8. Divide this side by 8. So finally, I can say t equals 15 over 8 hours. What the heck is that? 15 over 8 hours, right? We can divide, and that's 1 and 7/8 hours working together. Does that make sense? 1 and 7/8 hours. Well, if I can do it in 3 and Schrader can do it in 5, together we certainly should be able to do it in less time than either of us individually. So that's it for 7.4. That gets you up to speed for the first half of the week, and hopefully I'll see you tomorrow.